When sourcing solar panels and components for a 7.5 kilovolt ampere utility interactive system, several avenues can be explored to find reasonable prices. Firstly, consider online retailers. Solar Reviews, accessible at solarreviews.com, provides a platform for comparing solar installers and equipment. EnergySage, found at EnergySage.com, also allows users to compare quotes from multiple installers and suppliers, potentially uncovering competitive pricing. Eclipse at Eclipse.com is another online retailer to consider. Secondly, explore wholesale distributors. SunPower at SunPower.com is a well-known manufacturer that may offer wholesale options. LG Solar, accessible through LGsolar.com, is another manufacturer to investigate for potential distribution opportunities. Jinko Solar at JinkoSolar.com is also a major manufacturer to explore. Thirdly, industry events provide opportunities to connect with manufacturers and distributors. Solar Power International, or SPI, at SolarPowerInternational.com is a significant industry event. Intersolar North America at Intersolar.us is another event that gathers industry players. Other resources can also be considered. Costco at Costco.com/home/solar energy. HTML sometimes offers solar energy solutions. Home Depot at HomeDepot.com/b/heating, venting, cooling, solar energy, solar panels/n-5 Econovzy Cara solar panels and related equipment. Lulz at Lulz.com/pl/solar panels/4,294,853,741 also sells solar panels. To find affordable components, firstly shop around. Compare prices from multiple vendors before making a purchase. This involves researching different brands, models, and suppliers to identify the best deals. Secondly, consider used equipment. Used solar panels and inverters can sometimes be found at significant discounts. These can be sourced from online marketplaces, solar installers, upgrading systems, or salvage yards. Thoroughly inspect used equipment before purchasing to ensure functionality and safety. Thirdly, negotiate. Contact manufacturers or distributors to negotiate bulk pricing or discounts, especially if purchasing a larger quantity of equipment. Building a relationship with suppliers can also lead to better pricing. Fourthly, utilize rebates and incentives. Research government and utility programs that offer rebates or incentives for solar installations. These programs can significantly reduce the overall cost of the system. The database of state incentives for renewables and efficiency, or DSIRE, is a comprehensive resource for finding such programs. Finally, if possessing the necessary expertise, installing the system oneself can save on labor costs. However, this requires a thorough understanding of electrical systems, solar panel installation, and local codes. Ensure compliance with all safety regulations and obtain necessary permits before commencing installation. Remember that a 7.5 kilovolt ampere system is a substantial installation that needs to adhere to the National Electrical Code, or NEC, and local codes. You'll be dealing with alternating current voltages, likely 240 volts or higher, depending on your utility service. This requires careful planning and execution to avoid electrical hazards. When selecting panels, consider factors like wattage, voltage, and efficiency. Higher wattage panels reduce the number needed, simplifying installation and reducing racking costs. Open circuit voltage and maximum power point voltage are essential for inverter compatibility. Panel efficiency determines how much power is generated per square foot. Also, consider the inverter. The inverter converts direct current from the solar panels to alternating current for use in the home or grid. Select an inverter with the appropriate power rating and voltage range for the solar array. Consider features like maximum power point tracking, or MPPT, and grid tie capabilities. Don't forget about the racking system. The racking system secures the solar panels to the roof or ground. Choose a system that is compatible with the panels and can withstand local wind and snow loads. Check for corrosion resistance and ease of installation. Wiring and disconnects are critical components. Use appropriately sized wiring to handle the current from the solar panels and inverter. Install disconnects to isolate the system for maintenance and safety. Use appropriate grounding techniques to protect against electrical shock. Also, monitoring systems can be helpful. Consider installing a monitoring system to track the performance of the solar array. These systems can provide data on energy production, voltage, current, and other parameters. This data can be used to optimize system performance and identify potential problems. Now let's delve into some more specific technical aspects. Firstly, calculating array voltage. Solar panels are typically wired in series to increase voltage. The total array voltage should be within the inverter's input voltage range. For example, if you have panels with a maximum power point voltage of 30 volts and an inverter with a maximum input voltage of 600 volts, you could wire up to 20 panels in series. However, it's crucial to account for temperature variations as panel voltage decreases with increasing temperature. Secondly, calculating array current. Solar panels are typically wired in parallel to increase current. The total array current should be within the inverter's input current range. For example, if you have panels with a short circuit current of 9 amps and an inverter with a maximum input current of 30 amps, you could wire up to 3 strings of panels in parallel. Thirdly, wire sizing. Proper wire sizing is essential to prevent voltage drop and overheating. The National Electrical Code, or NEC, provides tables for determining the appropriate wire size based on the current and distance. Factors like ambient temperature and conduit fill also need to be considered. For example, according to NEC Table 310.15, B16, a 12 American wire gauge, or OG, copper wire can handle 20 amps at 30 degrees Celsius. Fourthly, overcurrent protection. Overcurrent protection devices, such as fuses and circuit breakers, are essential for protecting the system from short circuits and overloads. The size of the overcurrent protection device should be based on the wire ampacity and the equipment rating. For example, if a wire is rated for 20 amps, the overcurrent protection device should be no larger than 20 amps. Fifthly, grounding. Grounding is essential for protecting against electrical shock. The grounding system should be installed according to the NEC. Typically, this involves grounding the metal frames of the solar panels and the inverter. The grounding conductor should be sized according to the NEC. Sixthly, disconnects. Disconnects are essential for isolating the system for maintenance and safety. Disconnects should be installed on both the direct current and alternating current sides of the inverter. The disconnect should be rated for the appropriate voltage and current. Seventhly, surge protection. Surge protection devices, or SPDs, are designed to protect the system from voltage surges caused by lightning or other events. SPD should be installed on both the direct current and alternating current sides of the inverter. The SPD should be rated for the appropriate voltage and surge current. Eighthly, permitting and inspection. Before installing a solar system, it is essential to obtain the necessary permits from the local authorities. The system will also need to be inspected by a qualified electrical inspector to ensure that it meets all safety and code requirements. The inspection process typically involves verifying the wiring, grounding, overcurrent protection, and disconnects. Ninthly, utility interconnection. If the system is grid-tied, it will need to be interconnected with the utility grid. This typically involves signing an interconnection agreement with the utility company and installing a meter to track the energy produced by the system. The utility company may have specific requirements for the interconnection, such as the type of inverter and the location of the disconnect. Tenthly, monitoring. Monitoring is essential for tracking the performance of the system and identifying potential problems. Monitoring systems can provide data on energy production, voltage, current, and other parameters. This data can be used to optimize system performance and troubleshoot any issues. Now consider some additional aspects of system design. Firstly, shading. Shading can significantly reduce the output of a solar array. It is essential to minimize shading by selecting a location that is free from obstructions such as trees and buildings. If shading is unavoidable, consider using microinverters or power optimizers to mitigate the effects of shading. Secondly, orientation and tilt. The orientation and tilt of the solar panels can affect the amount of sunlight they receive. In the northern hemisphere, solar panels should typically be oriented towards the south. The tilt angle should be approximately equal to the latitude of the location. However, the optimal tilt angle may vary depending on the specific location and time of year. Thirdly, temperature. Temperature can affect the performance of solar panels. Solar panels perform best at low temperatures. The output of solar panels decreases as the temperature increases. Consider using ventilation to keep the solar panels cool. Fourthly, snow and ice. Snow and ice can reduce the output of solar panels. Snow can block sunlight and ice can damage the panels. Consider using a snow rake to remove snow from the panels. Fifthly, maintenance. Solar panels require minimal maintenance. However, it is essential to keep the panels clean. Dust, dirt, and debris can reduce the output of the panels. The panels can be cleaned with water and a soft brush. Sixthly, insurance. It is essential to have adequate insurance coverage for the solar system. The insurance policy should cover damage from weather events such as wind, hail, and lightning. The policy should also cover liability in case someone is injured by the system. Seventhly, warranty. Solar panels typically come with a warranty. The warranty typically covers defects in materials and workmanship. The warranty may also cover performance degradation. Read the warranty carefully to understand its terms and conditions. Eighthly, financing. There are several financing options available for solar systems. These options include loans, leases, and power purchase agreements, or PPAs. Loans involve borrowing money to purchase the system. Leases involve renting the system from a third party. PPA involve purchasing the electricity generated by the system from a third party. Ninthly, return on investment, or ROI. The return on investment for a solar system depends on several factors, such as the cost of the system, the amount of energy produced, and the electricity rates. It is essential to calculate the ROI before investing in a solar system. Tenthly, environmental impact. Solar energy is a clean and renewable energy source. Solar systems do not produce greenhouse gas emissions. Solar systems can help to reduce the reliance on fossil fuels. When choosing components, prioritize those with high efficiency ratings, as this maximizes energy production for a given area. Also, look for components with robust warranties, indicating the manufacturer's confidence in their product's longevity. Remember to factor in the cost of permitting and inspection fees when budgeting for the project. These fees can vary depending on the location and the size of the system. Also, consider the long-term maintenance requirements of the system. While solar panels require minimal maintenance, the inverter may need to be replaced after several years. Finally, it is highly recommended to consult with a qualified solar installer or electrical engineer before undertaking a solar project. They can help you design a system that meets your specific needs and ensure that the system is installed safely and correctly.